have two theorems that we're learning today, Rolle's theorem and the mean value theorem. We're going to start with Rolle's theorem. Rolle's theorem says, let f be continuous on the closed interval from a to b and differentiable on the open interval from a to b. If f of a equals f of b, then there is at least one number c in the interval a to b such that f prime of c equals 0. Okay, let's break that down. So f is a continuous function on the closed interval from a to b. So these are both x values. This is like an x1 and an x2. Continuous means that we draw without picking up our pencil. Okay, and it is differentiable on the open interval. So that's no corners and no cusps. And of course, because our function is continuous, we don't have any breaks in the graph. Your function is differentiable on the open interval because you can't be differentiable at the point, like the endpoints. We don't really care about those. Okay, if f of a equals f of b, so these are y values that equal each other. So that means that the y values of your two endpoints are equal to each other. Then there is at least one number c on the interval from a to b. So c is another x value, but it's between a and b. So it's like a is less than c is less than b, such that the derivative at c equals 0, or the slope equals 0. All right, let's take a visual representation of Rolle's theorem. So let's draw an xy axis, and let's put a and b on there. Let's put a here and b over here. Let's make f of a here and f of b here, because f of a equals f of b. So those two y values have to be identical for Rolle's theorem to apply. Okay, now we know that f has to be a continuous function on the closed interval from a to b and differentiable, so we're going to draw some kind of picture. Let's go and do something like this. Okay, it's got to be some kind of a smooth curve. Then what we are saying is that somewhere on this curve between a and b, our derivative or slope is 0. So is there any spot on that curve where the slope is 0? Looks like right here, a tangent line would have a slope of 0. So f prime of whatever that x value equals 0. So let's say that this is f prime of c. Then c is some number here in between a and b. Now, you might be thinking that, hey, what about if my graph looks different than this one? Let's draw a different example. Let's put x and a and b. Again, we're going to have f of a and f of b to be the same thing. It's going to be right there. And then let's draw, how about this? Okay, are there any spots where the derivative equals 0, the slope? Here, we would have a slope of 0, f prime of something. Here, we would have a slope of 0, f prime of something equals 0. And here, we have f prime of something equals 0. Rolle's theorem says that if all that stuff is true, there is at least one number for c. So here and here and here, all three of those spots could be c. So let's do like c1, c2, and c3. If the function is not differentiable, meaning there's a corner or a cusp, then this does not apply because at the very top, that maximum, the derivative does not equal 0. Our function is not differentiable there. The other thing, if f is not continuous, you might have other mins and maxes like something like a vertical asymptote like this. And like here's A and here's B. Since the graph is not continuous, there's no maximum or minimum. Your arrows just kind of go on forever. So there's not necessarily a spot where the derivative of c would equal 0. So that just wouldn't exist potentially. Okay, so make sure all that stuff is true. All this stuff has to be true. And then you can prove that there's at least one number where the slope would be 0. All right, show that Rolle's theorem applies to f of x equals x squared minus 3x plus 2 on the interval from x equals 1 to x equals 2. After we do that, so we have to prove that there is a value of c, and then in the second part, find the value of c that is guaranteed. So we're going to do some solving in the second portion. So first off, we have to make sure that our graph of f is going to be continuous. Well, what do we know about polynomials? So f of x is a polynomial. So f of x is continuous on the closed interval from 1 to 2 and differentiable on the open interval from 1 to 2, because polynomials are differentiable and continuous everywhere. Okay, cool. That's good to know. We need another thing. We need to make sure that f of a equals f of b. F of a has to equal f of b, so let's find it. What is f of 1 and what is f of 2? F of 1 is 1 squared minus 3 times 1 plus 2. F of 2 is 2 squared minus 3 times 2 plus 2, which is, let's see, 1 minus 3 plus 2 is 0. 4 minus 6 plus 2 is also 0. Awesome. So because f of x is continuous and differentiable and f of 1 equals f of 2, Rolle's theorem applies. You have to show that f of 1 and f of 2 actually get you the same number. You can't just say that they're equal, you have to show the numbers. So we have done all of this part. You just really have to say everything is true before that comma. Okay, then there is at least one number c in a to b such that f prime of c equals 0. Okay, so we are going to say that f prime of x equals 0 at some point. Let's find the derivative. X squared's derivative is 2x, negative 3x's derivative is negative 3, and 2's derivative is 0. So we know that somewhere 0 is going to equal 2x minus 3. Add 3, divide by 2. So 1.5 is the x value, which is also called c, where f prime of c equals 0, right? F prime of 1.5 equals 0. So we have proven that that value has to exist, and now we have shown what that x value is. What is the value of c? The mean value theorem is a more generalized version of Rolle's theorem. Okay. We still need to make sure that f is continuous on the closed interval and differentiable on the open interval. Okay, as long as that stuff is true, then there exists a number c in a to b such that f prime of c equals f of b minus f of a over b minus a. Now, we have seen this formula a whole bunch before. F prime of c means the slope at one point. And then this fraction is the slope formula between 2 points. So somewhere there is the slope of 1 point, and that is going to be equal to the slope between our two endpoints. So what do we need to do? We need to find the slope between our two endpoints. Okay, then we need to find what is f prime of x, what's our derivative, and then solve to figure out what c is. What is that x value? So reading through just down here, there exists at least 1 point on our interval between our endpoints where the slope of the tangent line equals the slope of the secant line drawn between the two endpoints. So here in blue, this is f of x. We've got a tangent line. And then if we find the slope of the secant line, what do you notice about the slope of the secant line and the slope of the tangent line? They are the same, so they end up being parallel. So both of those slopes are the same number. That's the goal. So let's do some examples of the mean value theorem. Suppose that we know that f of x is continuous and differentiable on the interval from 6 to 15. Heck yeah. So we've got most of our theorem proven so far. We also know that f of 6 equals -2 and f prime of x is less than or equal to 10 for the interval. What is the largest possible value for f of 15? Okay. So the mean value theorem says that if f is continuous on the closed interval from a to b, here in the box, and differentiable on our open interval from a to b, then there exists a number c in a to b such that f prime of c equals that fraction. So we are able to use this theorem because everything before the word then we know is true. Okay. We know that f of 6 is -2 and f prime is less than or equal to 10. So the slope is less than or equal to 10. We want to know what is the largest possible value for f of 15. Well, we know that f of b minus f of a over b minus a has to equal f prime of c, or f prime of x, so any like x value. We know that f prime of x is less than or equal to 10 on the whole interval. So this fraction, f of b minus f of a, has to be less than or equal to 10, right? All the slopes have to be less than or equal to 10, so the slope between our endpoints also has to be less than or equal to 10. Okay, well, we know that b is 15 and a is 6. So let's solve this the best we can. We've got f of 15 minus, let's see, f of 6 is -2, so I'm going to put plus 2 there, over 15 minus 6 is 9. It's less than or equal to 10. And then our job is to solve for f of 15 because it's just the last thing that's there, and we want to know what is the largest possible value for it. So we will multiply by 9 and then subtract 2. Multiplying by 9, we get f of 15 plus 2 less than or equal to 90. I don't know why I put that parentheses there. We're going to subtract 2 from both sides, and we get f of 15 is less than or equal to 88. So the largest possible value for f of 15, that y value, is 88. That's not a very common problem. Usually we are solving to find the C value, so this next one's going to be the more common problem. Here we go. Determine all the numbers C which satisfy the conclusion of the mean value theorem for f of x equals that cubic function on -1 to 2. So first off, we need to show that the mean value theorem can be used. How do you know you can use the mean value theorem? Well, you have to say that f is continuous on the closed interval and differentiable on the open interval from -1 to 2. F is a polynomial. F of x is a polynomial. So f, where f of x is continuous on -1 to 2 and differentiable on the open interval from -1 to 2, because polynomials are continuous and differentiable everywhere. So the mean value theorem applies. Okay. So can you use the mean value theorem? Yes, if these two things are true. You have to show that that is true. If we were trying to use Rolle's theorem, we would also have to show that f of -1 equals f of 2. We don't necessarily know that. Okay. What we do know is that the mean value theorem is true, so it applies. F prime of C equals f of B minus f of A all over B minus A. We're looking for like the f prime of C bit. If f of x is x cubed plus 2x squared minus x, then f prime of x equals 3x squared plus 4x minus 1. Agree with that derivative for this. Okay, so this right here is going to go in, we're going to need that. What does f prime of C equal? It's going to equal that fraction. F of B and f of A we have to find. F of 2 and f of -1. Okay, so we need 2 cubed plus 2 times 2 squared minus 2, and then -1 cubed plus 2 times -1 squared plus 1, because minus -1. So this is 8 plus 8 is 16 minus 2 is 14. And down here, -1 plus, that would be a positive 2, plus 1 equals 2. So f of 2 is 14. F of -1 is 2. B was 2, and A is -1. So f prime of C has to equal 12 over 3, which is 4. So the slope between our two endpoints is 4. Slope of the secant line between two endpoints is 4. Then somewhere for some value of C in between -1 and 2, that slope is also going to be 4. In Rolle's theorem, we set our derivative equal to 0 and solved because the slope between the endpoints was 0. Here, f prime of x, or f prime of C, whatever, is going to be 4. So instead of setting our slope equal to 0, we set it equal to 4. Okay, that is the derivative somewhere. Now we have to solve this little equation and get x by itself. You cannot solve unless it equals 0. So 0 equals 3x squared plus 4x. Subtracting 4, we get -5. And then we can use the quadratic formula or a calculator to solve this out. You guys know how to use the quadratic formula, so I'm just going to tell you what the answers are there. It's x equals 0.786. Make sure you're using 3 decimal places. And x equals negative 2.120. Our interval is -1 to 2. This does not fit into that interval, so this is the only number that works for our x values. Now, how are we going to apply the theorem? We've got Ben that is riding a unicycle back and forth along a straight east to west track. So he goes east, he goes west. East means he's going to the right, west means he is going to the left. The twice differentiable function b models Ben's position on the track. Okay, so b, or b of t, is his position in meters. And v of t is going to be b prime of t, the derivative. When t is between 40 and 60 seconds, there must be a time t when Ben's velocity is 2 meters per second. Or that backwards. Must there be a time when Ben's velocity is 2 meters per second? Okay, so we want to know, is the velocity, which is b prime of t, equal to 2 anywhere between 40 and 60 for sure. So let's set up the mean value theorem. The mean value theorem says that b prime of t is going to equal b of b minus b of a all over b minus a, right? The derivative, the slope at one point, is going to equal the slope between the two endpoints. Okay, be careful because over here, our very first endpoint is a 0. We only care about 40 to 60. Okay, so b prime of t equals b of 60 minus b of 40 over 60 minus 40. B prime of t equals, let's see, b of 60 is 49. B of 40 is 9 over 60 minus 40. So b prime of t equals 40 over 20, which is 2. We have to show that we are allowed to use the mean value theorem. We're allowed to use this formula in order to prove that b prime of t equals 2 somewhere. So how do we prove that? We need to show that b of t is continuous and differentiable we are told that b is a twice differentiable function. If b of t is differentiable, then b of t is also continuous, because b of t is differentiable, b of t must be continuous. Okay, that is true. Differentiable functions have to be continuous. If a function is not continuous, it's not differentiable. Okay, so b of t is continuous and differentiable, so the mean value theorem applies. The mean value theorem guarantees a time in the interval such that b prime of t equals 2. Mean value theorem guarantees a time in the interval from 40 to 60 such that b prime of t, which is v of t, equals 2. That's it. So we have to show that the theorem applies, and then you can say that the slope between your two endpoints has to equal the slope at one point somewhere. And that's it.